So I have the pleasure of introducing you today's speaker, Bryan Smith. So Bryan is the co-founder and CEO of ThinkData, a Toronto-based technology company whose platform is used by some of the world's largest organizations to process and refine data into usable products. So welcome, Bryan. Thanks for joining us today.
Thank you. I want to start by thanking Communitech and ODX. Both organizations have been with us since the early days of us starting the company. We were originally a Communitech company and really leveraged the network to get started with our initial clients, including Thomson Reuters, which is here today, and a relationship that we still kind of work with. So I have nothing but great things to say about the community and everything they're doing here because it led to our early success, and we can definitely lean on that as a good story for starting our company. A bit more about me. So Bryan Smith, we started ThinkData about four and a half years ago. Prior to that, I was actually working at the federal government. So I did this weird thing where I went from being a government employee to being a startup founder, which is a story for another day. But working at the Government of Canada, one of the big things that I focused on was Canada's Open Government Partnership and the Open Government initiatives that we launched back in 2012. And really the point of today's discussion and a lot of what the ODX is doing is around Canada's leadership in their open data strategy, as well as launching Canada's first open data portal. So that was a lot of work we did back in the government. And what ultimately led to the transition of starting ThinkData and helping companies work with open data coming from governments all over the place. Since then, ThinkData is really focused on finding a way to turn the raw material that is data that governments are publishing, every level of government, whether it's a city, state, province, federal governments from around the world, into a refined, usable product that organizations can plug into and start actually adding value to their existing products, services, internal data, really bridging the gap between internal and external data. From a high level, that's ultimately what we've always done as a company. I think just like any other startup, we've transitioned from being our initial vision of a pure data platform sort of marketplace into more of a tool set that enables organizations to take data and actually start working with it. Where we kind of land on the spectrum is a true data platform. So what we mean by that is we want people and companies to build applications and build solutions on top of our platform. And we want to be the underlying layer that works as sort of the data infrastructure that facilitates the flow of data from wherever it's coming from, potentially thousands of different places and thousands of different formats. Normalizing all of that into sort of a common stream of data that companies can then build apps and products on top of. And we really work well with data scientists who I think they're the ones that end up doing a lot of this custodial work. We want to kind of unlock their time so that they can spend more time doing the actual data analysis and the things that are going to drive real business value, rather than that sort of underlying infrastructure work that takes up a lot of time. So hand in hand, we work really well with them. Where Namara, which is our platform, where it's kind of evolved to today is really that concept of being a general platform. So we talk about being the easiest and most secure way to access, collaborate, and integrate with the data that powers your business. And what we mean by those three words, access is both accessing new data that maybe the organization has never looked at before or has never had the ability to connect with, but also taking open data principles and applying it to internal data. Access is also just adding visibility to the data that is available to the data scientists within an organization. Right now we see a lot of data silos within organizations, and that really stops organizations from being able to innovate and build products on their own data. Access to us means accessing that world of open data, but also adding that layer of visibility so that we can build products and tools with all of the available resources we have within a company. Collaborate, we're trying to make it really easy for organizations to share data internally, build teams around data, allow data scientists to see the data they have access to, brainstorm, whiteboard, and build products, build them very fast, and then put them into production when they're done. and then integrate, making it very simple to integrate with any sort of business intelligence layer. So we don't provide our own sort of visualization or analytics software. We integrate with any application that an organization has either built themselves or bought, like Tableau, Power BI, whatever. We're just looking to actually fuel that sort of that product that they're building. So diving into a bit, I think where we're seeing a lot of action in this space is really companies that are starting to think of themselves as data-first companies. And what we sort of consider a data-first company is a company that understands that the data they're generating is not a byproduct of their business. It's actually the fuel that's going to power the future of their business moving forward. And we're seeing a huge divide starting to happen in the marketplace between companies who aren't taking their data seriously and those that have decided that they really do need to double down on data and start actually working with it in a way that's going to drive their business forward. Data-first companies are going to be the first trillion-dollar companies. I made this slide a few months ago before Apple announced becoming the first trillion-dollar company. My bet was that it was going to be Amazon. And I got a next slide that hopefully validates why I thought that. But now that we've seen Apple, which is absolutely a data-first company regardless, break that trillion-dollar barrier, I think we're going to see it kind of mimic the 4-minute mile in marathon running. As soon as one person broke it, we're going to see all these other companies start breaking it as well. I think we're going to see Google and Amazon come very, very soon to the trillion-dollar marketplace. But their businesses are all driven on data at this point. Whether they're selling anything through an e-commerce platform or whether they're selling computers, at this point, all of their decisions are being made on the data that they're bringing in, and they're pushing out products that are pushing more and more data through their company, which I've got a picture of sort of the home suite here. At the end of the day, these are data collectors that everyone's putting in their home voluntarily, but the real value to this business is not the product itself, it's the application that these guys are building on the back end, which is becoming a personal AI assistant. All built on the back of data that we're ultimately giving these guys for free. If you want to learn more about this, I recommend reading this book by Scott Galloway, The Four. It goes through each one of these 4 companies, Facebook, Google, Amazon, and Apple. Really good read. He's a Wall Street guy, so it's got that like investment sort of feel to it, but really good book and kind of talks more about that last slide I had. So bridging back to Amazon and why this was my sort of bet on why they would be the first trillion-dollar company. From a data perspective, I don't think I need to tell this room that Amazon's a data-first company. Their data requirements were so crazy that they built AWS for themselves and started selling it. And it ended up actually being the only reason they were cash flow positive. If we look at them compared to their market cap, when I made this picture in May, there was 769.9 billion, which is basically double the next 10 closest commerce companies that they compete with. And they're doing this not because they're selling different products or entering a different part of the market that these other companies are also selling into. They're doing it because they're selling stuff data first. And I think we can all remember when they first introduced the recommendation engine. That was something that started in an internal hackathon at Amazon, which was, hey, can we push products that people may want based on their searches and on the things they bought? And that's so second nature to us now, but 5-10 years ago, that didn't exist in their app, and it was just something that they thought would be cool. That's basically the reason that they've completely owned this entire market and why they're well on their way to become the second trillion-dollar company. This is in Scott Galloway's book. When he wrote the book last year, they were at 432.9 billion. I updated it 12 months later, which put them at 76.9 billion. I checked on the weekend when I updated this slide. Currently, they're at 929.3 billion. So I think we're going to see them cross the trillion-dollar mark relatively soon. I think what data-first companies do very well, and what Amazon has shown that they do better than anyone else, is they've been able to translate data collection and analytics into a product that they can deliver to their users, similar to how they actually ship products out the door. And I think this is probably the thing that we see the largest issue with most of the clients we deal with, is there's not enough focus on that last mile of delivery of getting data out the door. Companies are really good right now at identifying how to collect data. We're pretty good at storing it. We're pretty good at making it available to people, albeit in silos. But where there's a lot of issues within companies is how do we then translate that into a product, a service, something that actually drives revenue for our business or provides a better service that puts us ahead of everyone we're competing with. When we talk about this with our clients, we really call it the last mile of delivery. And I think it's an easy topic to sort of understand if we think about even getting a product that Amazon's shipping out the door. The hardest thing they have is that last mile of delivery. They can get people to buy something with one click. They can put AI in their warehouses so that they can ship it within a couple hours. But at the end of the day, if they miss the US Post guy who's coming to pick up the package, it gets delivered the next day. And that's what Amazon, I think we're going to see them invest a lot in, is this last mile of delivery. And I think that case study translates perfectly to the world of big data. We've got all this other stuff figured out. There's thousands of tools in the marketplace that get us to that last phase, but it's up to the company to decide how they're going to get that last mile delivery of data out the door. And it's a really difficult problem to solve. What we ultimately see, which is a stat we've pulled from Technology Review, because there's not a lot of focus here, companies on average only ever analyze about 0.5% of the data that they're collecting. So we can see it that they're creating it, they're collecting it, but at the end of the day, they're not really doing anything with it. A lot of this stuff is showing up in small proof of concepts. They're running it, but turning a huge data project into production at one of the big banks or insurance companies is proving to be pretty difficult for a lot of the data and innovation people that are working on the ground. And I think the data teams and the technology teams are running into a bit of issues when trying to translate this to executives and more of the C-level that sit outside of the tech world. Because they've asked for a lot of investment in things like infrastructure, ETL tooling, analytics platforms in order to actually collect data and turn it into something. But a lot of investment isn't happening in actually turning that into a product that can be shipped in some sort of capacity. So when we talk to the clients that we work with, we really try and focus in on this last mile of delivery and say, you can make hundreds of millions of dollars of investment in sort of the top layer. But if you don't focus resources and give your data scientists the tools they need to turn this into a product, you're going to run into this at the end of the road, which is none of your information is actually being turned into anything that's going to drive value for your business. We've got a quote here from Arthur Nielsen, who started Nielsen Analytics, which is the price of light is less than the cost of darkness. I think he used that to sell his business, but I think it's a good one to think about, and one that we often drop on CEOs and CIOs. A lot of them have spent hundreds of millions of dollars on data infrastructure, and that money's lost unless you double down and actually turn it into something that's useful. That number, I think, becomes a bit more important when we start looking at some of the new research that's coming out of Gartner and Forrester. This one I like a lot, which is by 2021, insights-driven business will steal 1.8 trillion a year in revenue from competitors that are not insights-driven. And what I like about this is, in the past, we've seen a lot of consultants and Forrester and Gartner and the rest talk about the value of data and the value of external data and plugging into it, and they've attached these big numbers to it, like, hey, this is a $5 trillion market, $5 billion market, whatever. This one's interesting because of the word steal. And I think that should catch the attention of a lot of executives because it's not net new revenue that we're adding to businesses that we could potentially survive by ignoring. This is my competitor being better than me at doing something with data that's physically going to steal money that I count on currently to make my business operate. And that slight change, which I'm not sure if Gartner did it on purpose or not, I'd like to think they did, should really scare people. It's one thing to talk about new revenue, but looking at your fiefdom and seeing it melt away over the next few years is a very different mindset, and one that I think the entire executive class at every company needs to start actually thinking about and understanding why they need to invest in a sort of last mile of delivery, an external data strategy, and how to actually start shipping data as a product or a solution out the door. Forrester, I think a lot of this number was driven by this whole new push on artificial intelligence, which has kind of swept the entire technology scene, including the big data scene. We can't have a single discussion with any company about data without talking about artificial intelligence in some sort of capacity. My second book recommendation would be Prediction Machines, which is written by the U of T professors who started up the Creative Destruction Lab and kind of run the Vector Institute now. And I think this is they make a very clear case as to why we're in the artificial intelligence boom that we are in now, which is the idea that artificial intelligence doesn't necessarily bring us intelligence. It brings us a component of intelligence, which is prediction. And that's ultimately what everything we're building in the startup space is pushing towards, is being able to predict an activity by looking at the data we have and making a human-level decision on the outcome that we generally don't know. So this is something like, I always use the example of Salesforce. Every day, Salesforce, salespeople sign up and they look through their lists and they decide who to call. Where we're heading on the enterprise side is to have tooling come in and start telling the salesperson who to call based on a bunch of things. Hey, this person is selling a house. This person got appointed to a board. Maybe they need a new insurance product. Maybe you should call them and say congratulations for getting married or having a kid and start that discussion. Right now, that relies on the salesperson themselves to make that decision and know that information. Where we're heading is into a world where the tools we use on a daily basis in the enterprise world are going to start telling us where we need to focus our time. And that's really what I see where I see the big push in enterprise AI, and why it is really a big deal that every company needs to focus on. It's not just a trend that's going to disappear. In the B2C world, a lot of the apps we have on our phone, if we all looked at our home screens right now, are all predictive in some sort of capacity, whether it's the weather, or whether it's your email. It's trying to tell you to do something. In the B2B world, that hasn't quite come to manifest yet, and we're going to see that over the next few years. I think 2021, that's sort of where Forrester is kind of focusing their time. So I think although this has a lot of value to drive for the business, we start bumping up the reality of how enterprises are organized, and one of the biggest trends we see this year is an interest in automating the data prep process. To date, we've seen organizations really invest in data scientists and kind of throw teams of data scientists at the data problem and say, hey, we've given you the infrastructure to store data and to access it, and we've bought you the analytics solutions and BI tools that are going to drive value for the business. Your job is to do everything else. It's to find the data, turn it into a usable product, build the models, prove that it actually adds value, show the ROI, plug it into the tool, and then have our team run with it. And ultimately, what this whole sort of solution creates is a problem that data scientists end up spending nearly all of their time doing data prep, cleansing, finding, normalizing, all of these tasks that at the end of the day can be automated with tools that we already have in the marketplace and we already have available in a lot of these organizations. We just have to start shedding light on how we can help our data scientists use their time properly to actually be scientists rather than custodial staff that are going in and kind of building this stuff out. And one of the biggest trends we're seeing in the market now with a lot of large enterprises is looking at how we actually aid our data scientists, look at them as actual scientists and say, what tools do you need in order to run your experiments? We don't want you to build everything. We don't want you to manage new pipelines. We don't want you to go out and find external data because that's not the best use of your time. We can do a lot of that stuff for you, and you can focus on the high value stuff that we actually hired you for, which is driving new revenue for the business, building new products, making the business better. So I'm going to transition this into some of the three big issues that we see companies dealing with, specifically around the external data world and how to just start working with data that is not native to your business. We've built a bunch of tools to handle it, and we've got strategies about how we deal with the data that we have on our platform. And I wanted to share those today and just walk through why we actually built the tools that we did and how we use them and the problems that they ultimately solve. So I'll start by sort of outlining the 3 big issues that we see companies facing. When we go in and tell a company that, there's a whole world of external data out there, you're probably not plugging into everything you can, we can probably make your services better. These are sort of the 3 things that always come up. The first one is access and availability. So we show up to a data team, we talk to a chief data officer, and we say, hey, insurance company X, there's a lot of data about people out there that could really tell you a lot about your business and about your prospects and your clients. You should start plugging into it and providing a better service. And in this particular case, a lot of the pushback we get is, well, we don't have any time to actually go find this stuff. We have so much data that we're generating ourselves internally that our data teams are already drowning. How would we ever go out and even find that there's a data feed regarding house pricing that we can start using? And beyond that, even if we did find it, how do we validate it, first of all, that this source is real? And how do we keep it consistently updating and flowing into our organization? The amount of work that we would need to do in order to start using that data is such an investment that I don't know if we can make it either on a time or on a cost because we don't know what the ROI is. Therefore, our decision is to completely disregard external data altogether and just work with what we have internally. Huge pushback. We hear it basically at every discussion we have. And I think a lot of this problem is really based around data science teams being strapped for resources. Not so much in needing more people, but being able to focus your resources properly on the high value stuff and look at providing the tools underneath that are going to automate that discovery process and all of that sort of fun stuff. Which kind of takes us to our next point, which is automating data prep. I think this is where, when we talk about artificial intelligence and hear everyone talking about artificial intelligence, it's often focused on building a solution for the market. The one thing that we do at our company, and we push on a lot of people, is why don't we take all of that AI advancement and actually look at it internally and focus it on data prep? So can we find ways that actually take developments in machine learning and prediction and let that loose on data we're trying to bring into our company so that when it does eventually enter our company, it makes sense, it's linked, entities are resolved, external data is immediately linked to our internal data, and we now have a usable product that we can immediately just start leveraging. So a lot of the focus that we've been doing at ThinkData is looking at machine learning tooling, but instead of trying to build applications on top of it, on top of data, actually build applications that go ahead and target fixing data in a way that is really scalable when dealing with massive, massive amounts of data sets. And the whole goal of that is just to make it as simple as possible to turn on a new data set within an organization and immediately start leveraging the value you can get out of it. And then there's the whole monitoring and scaling piece. The big difference between working with external data and internal data is in the world of external data, you don't own the resource. It's not in your company. You can't call the person at the end of the day who's managing it and ask them why they changed a bunch of things in the data set or why they're a week late on pushing an update. We learned this the hard way when we started plugging into thousands of government portals across the world. And to this day, we have governments completely change the way that they publish a data set on a monthly update, and then the next month go back to the old way of publishing it. And it's just one of those things in the external data world that causes huge problems. And when companies try and plug into external data without the proper toolkit to monitor the data, keep it flowing in, doing all the data processing, we find one of these changes will break whatever product or solution that they've built. And sometimes the organization doesn't realize for months that they're not collecting data. In other ways, the change in the schema will break the entire app itself and pull it down, which will piss off a bunch of people within the organization. And let's say we're scrapping this project because it's not reliable enough. There's this whole layer that should sit underneath those applications that monitors all of this stuff going on and can catch those changes and fix them before that data flows into the production environment. And that extra layer of ultimately security is super important when dealing with external data or any data where you don't control how it gets published, when it gets published, and where it's getting published from. So that's sort of what we talk about on the monitoring, and also scaling. Sometimes you can deal with that on like 1 to 10 data sets, but we've got organizations that are ingesting thousands of data sets through our platform, and it's just not humanly possible to monitor thousands of data sets that are all changing and growing over time. So I'll walk through sort of some of the tools that we use and that we built ourselves. The biggest users of our platform are us at the end of the day. Namara is a tool that clients deploy in order to access data and manage their data sets, but it's also the tool that we use internally to manage our entire catalog of data. So currently we have over 250,000 data sets coming from a couple thousand governments all around the world. We also have a bunch of data partnerships with organizations that are selling data through our platform, so Crunchbase being an example. And Namara for us is a way to manage that entire repository of data, which we don't control at all. None of the data is stuff that we generate. It's all coming from a different place. So when we started the company, the whole goal of it was to build this platform that made this data available. But then we realized we got really good at managing that data variety issue and neutralizing it. So that's sort of why we built our data platform, our data marketplace. And I think the most important thing for us was really building the data collaboration piece. So we took an early stance very early on that one of the biggest problems with data was that people downloaded it in a CSV, put it in an email, and emailed it to each other, and then consistently did that, and that became part of the process. So we looked at it and said, why don't we build a dashboard that allows people to build teams and projects around data, where the data in that project is going to stay consistently updated, and everyone who's invited to it will always see the most updated version. So we're eliminating sort of the versioning problem of downloading data and shipping it. And I think it's a similar problem that Dropbox solved with documents back when Dropbox launched. People were emailing documents to each other with versions on it, and everyone lost control of the versions, and it was just a weird thing happening. The same problem is going to start happening with enterprise data as data gets leveraged in more and more different parts of the organization. And there really needs to be a clean way to access it, control, role management, and all that sort of fun stuff. So ultimately, that's what we built through our platform, and it's the tool that we use more than anything else to actually control our complete repository of data. The next step after actually being able to manage the data turned into this concept of neutralizing data variety. And then how do we actually start merging it with internal data within companies or within our own information on the platform itself. So it was one thing to collect data from 1,000 different places and normalize the format so that we could ingest it through an API. It was a completely different problem to take very similar data sets coming from hundreds of different places and turning it into a single standard data set with a schema that would be constantly updated by all of the individual data sets itself. So an example of this would be school locations. Every city across Canada, the US, publishes a data set through their open data portal that tells you the locations of schools. Every single one of those data sets is represented slightly differently. It's the same underlying information, school name, address, board, that sort of stuff. But everyone who fills out that data set organizes it slightly different. So how do you take thousands of data sets coming from governments all across the continent and turn it into one single data set that we can plug into and grow over time? And that's really what we started building with Unity, which was a project that was partially funded through the ODX as well from a development perspective, which is what we see on the screen now. And what Unity really helps us do is it helps us take any number of data sets. This particular example has 51 or so, and merge that raw input that you're seeing on the left-hand side into our standard output. And what we can do with this is grow it over time, evolve, and really just build that one single standard data that turns a really messy data problem into a really clean one. And that's what we found was really the linchpin for working with our clients and unlocking the power of open data within the enterprise. Was none of the data that was being published by the government covered enough geography for a large bank or a large insurance company to take it seriously. They'd look at the Toronto Open Data Portal and they'd say, oh, it's great that you guys have housing data, but we're national, if not international. We need this for the entire country. And by the way, we're not going to go out and plug into 1,000 data sets. So that's what we use Namara for. And we continuously build tools into Unity, to solve a bunch of problems. But when you really start looking at external data as a source of hundreds, if not thousands of data sets to manage, if you don't have these tools, you can't stay updated on the data. And if you can't stay updated on the data, things are going to break and production is going to go down. And looking at thinking about the underlying infrastructure as a way to keep your production environment consistently up to date is really what we kind of focus on with a lot of our organizations. So that's sort of what we use and what we built ourselves. The big thing the reason we built all these tools ourselves is we ultimately didn't really want to at the end of the day. The original point of the company was to help organizations jump into new external data feeds. These things all sort of came out of necessity. We had conversations. Our original clients plugged into raw data directly through our platform. And all of these things that we've built have come out of the necessity of them needing it in order to scale. And I think the one big problem that we're seeing companies deal with now is this whole big data world has turned into a gigantic mess, and everyone is selling an end-to-end solution that can get you from A to B, from the big data world to whatever application layer you're plugging into. And the options are ultimately endless. I think if we start talking about throwing data scientists into a company and telling them to build something that will deliver data from A to B from anywhere in the world to a product that we want to launch internally, what we're ultimately asking them to do is say, take a look at this and build something. We have no idea what it is. You'll have to look at all these companies. You'll have to decide how to duct tape them all together. And you'll have to tell us how much it is, and then we're going to put something into production. And by the way, you got to go also find all the data that you then want to run into it. And what we find is this is a 3 to 5 year roadmap, and it's a couple $1,000,000. Building all of this stuff together is just a huge project, and it takes a specific person to do this. And that person is one of the most sought after data scientists / engineers in the marketplace. We compete with Amazon on these people all the time because that's what they're doing and that's what they're building. And I think this is where companies get themselves in a lot of trouble is they look at building these sorts of pipelines to turn on really small projects as large data infrastructure projects that historically have been $100 million big data undertakings at a company like the big banks and insurance companies, which I'm picking on, but lots of companies fall into that category as well. And when we start looking at external data, we really don't need it to be that huge project. What's more important is, can we build something as fast as possible that shows some sort of ROI? And can we do it in an environment that can slowly scale over time? That's ultimately what we try and pitch with the tools we built, because it's how we built the company. And that's sort of the build versus buy that we always run up against when we talk to large organizations is, this shouldn't be a $50 million project that's going to take you 5 years. Because if that's your approach, your competitors are going to move a lot faster and they're going to be stealing that 1.8 trillion that Forrester's talking about. We really need a fast go-to-market strategy with this, and there is technology out there that can get you from A to B in months instead of years. So on top of this sort of infrastructure layer and big data layer, I think the other thing that's very confusing to a lot of people right now is what I call the insanity of the AI ecosystem. So not only do organizations have to deal with the big data and infrastructure that's going to be orchestrating data throughout the organization, now they're bumping up against every startup in Canada, what's the number here, 650, that are all trying to create a specific piece of artificial intelligence that's going to target a specific deliverable within a company. So as a data scientist, you're starting to get pushed on both sides. And I think you kind of get wedged in between these two environments, which is, okay, I'm supposed to solve this problem of shepherding data into my organization, but I don't know what I need to buy and I don't have the budget to do it. And on the other side, I'm supposed to build tools that are going to be AI-driven and drive new revenue, which all of these startups are starting to cannibalize even my ideas. So I get stuck in this area where it's like, okay, what is my job in the future in 2 or 3 years? And this is, I think, one of the biggest things that we're trying to educate the companies we're dealing with, is these two environments need to kind of flow together, and your data scientists need to be getting above all of this sort of research and all of this building into actually understanding your company and understanding what needs to be built and what needs to exist in order to power that. That's sort of, that's, I think, the interesting point where a lot of companies are at now. So on that note, that's all I had. I thought we'd take the last, I think we have 20 minutes and do question. Does that make sense? I got a box for you. Throwable. All right.
So yeah, you mentioned bringing things in and keeping them up to date and doing your entity resolution. That's great. What can you talk a little bit more about how you deal with conflicting values for a specific entity?
Conflict, can you give me an example?
Yeah, so the population of Berlin, right? What is the population of Berlin? People say it's 5 million. Well, that's an estimate done in 2005 by this person. Now, if someone says it's 6.2, it's a different person in 2011. All these caveats. There's no like true well, there is a true definition of population of Berlin, but no one knows it. And how do you deal with all those different values with those caveats on them?
Yeah, so what we've been doing is we kind of solve this in two ways, and I'll say it in upfront. It's probably not the best way to do it, but how we generally solve it is putting a competency rating on an actual source. So we can pull a number in from 10 different sources that all say, hey, the population of Berlin is between 5 and 7 million. Ultimately, one of those sources is going to be the Berlin government, and one of those sources is going to be the hottest new survey that just went out the other day. And then a bunch of them are going to be things that we can reference over time, whether it's news articles or whatever. So I think how we generally solve it now, which again isn't perfect, is how do we identify the competency rating of those sources and then average out where we want to end up. We could, depending on how conservative or liberal you are on how you want to look at the data, we could be conservative and only focus on the government's numbers, or we could be take a blend of all of them and create kind of an average and say, hey, this is what's going on. Or we could look at the newest thing that just got published and say, we think newest is most accurate, therefore we're going to run with that. But at the end of the day, we can set that competency rating. And as we add more and more data, we just kind of create a approach where we're building out a sort of pecking order for what data we want to look at and what we want to do with it.
Yeah, so a quick follow-up to that. Are you curating these data sets then? Because it feels like coming up with the averages for each of these values or confidences on these data sets doesn't really scale.
Yeah, so we actually built that into our Unity platform because people started asking for it. So if we look at Unity, we started building a bunch of nodes that actually do these computations. So we can start generating columns that enrich the data set with new information. So if we've got a bunch of rows we need to kind of concat into something, or if we have to do some calculations on some of the data that's in the data set itself, we actually use our Unity tool to build that out and then add that column into the data set that's going to be like the ideal at the end of the day. Yeah. Any other questions?
I had a question about, you mentioned the 250,000 data sets or what have you, but I think there is a very long tail, which means that outside of those 250,000, maybe 1,000 are very useful to a lot of people, but the 249,000 are either so sparse or so immaterial that they don't matter, right? So now your platform is spending or is putting in value in those data sets by kind of doing this entity conflict resolution, whatever, making the data better, right, to work with. So at what point of time do you decide that it's not worth that effort for a certain data set, right? Like,
yeah, good question. So we let the market dictate what we focus on. As a startup, we have to do it. I'd love to spend all this time on all of this data that's being published to turn them all into amazing products. But at the end of the day, if no one wants us to focus on lists of elected officials from different cities across the U.S., then it's something that we can't focus on. There definitely is the 1% of data that's coming through that is leveraged by everyone, and we have that list, and generally speaking, everyone plugs into it. The one thing that we've come to realize, though, is that data set that is deemed not as important, if it were to actually be merged and cleaned up, its value exponentially grows. So something like city financials for, or like pension funds investments for various cities. Where are cities and the unions investing their money in what pension funds? On a city-by-city basis, that seems like a super boring data set. But looking at all the US, putting all of that information together into a single data set and saying, hey, here's where all of the pension money in the US is actually invested, and here's the health of the funds, that turns into a product that becomes very interesting to the financial sector. I think it's being overlooked now because no one's put that effort into building it out. And it may be sitting in our database somewhere as a bunch of random data sets that we haven't put any time into. But as we kind of move the conversation forward with a bunch of enterprises, and as they get a bit more curious as to what is available and what they can do with it, we start uncovering these like really cool projects that ultimately is just pulling data together and building a useful product. But that's a slow effort, and it's growing over time, and it's really driven by market focus.
Hi. Do you guys have any plans for non-structured data parsing? So, for example, looking at video feeds and gathering temporal or non-temporal data out of that?
Generally speaking, no, not for the time being. We've started looking into images. That's as far as we've gotten so far. I think, again, good startup principles. Someone probably does that better than we do, so we don't do it at all. And that's sort of how we ruthlessly decide to focus our effort. Structured and semi-structured is what we're best at and what all our tools handle. I think over time, like any business, we've got goals to grow that, but for the time being, unstructured is another realm.
Focus and grow, right?
Exactly.
No question yet.
I think Joseph had one back there.
Just throw it, okay?
That's the first time I've actually ever caught this thing. It's kind of cool. So thank you so much for coming, Bryan. I had a question for you. So what have you, to the extent that you're comfortable talking about it, what have you seen as the breakdown for usage of your platform between folks doing things in terms of analytics, folks training machine learning models, and folks using your data to power sort of online or end user facing applications? What's that split been so far?
Good question. So what's the split between analytics, products, and general research, is that what you said?
Well, like, so people using it to train a machine learning model or using it to power like an online application.
Got it. So we exist in an interesting world where a lot of our clients are large enterprises and banks, insurance companies. They ingest their data and they don't have to tell us what they're actually doing with it, which unlike I think some of the applications in this graph, which are doing like particular analytics solutions, we've found like out through these companies that they're using, that our existing client is actually using our data feeds to power the AI solutions that they're building. So we're actually one step removed as the data platform. So I'll answer the question just on like what I know and what I don't know, but it may be completely different because at the end of the day, they can build anything on the platform and they don't really need to tell us. From the stuff that we work on closely with our clients, a lot of it's just on actually building real-time analytics that either get published to users or get published internally in order to make better decisions. We do a lot of CRM integrations. I think there's a lot of focus on getting, arming the front line with valuable real-time information and flipping the switch from being reactive to proactive in a sales cycle. And I think I would consider that sort of internal because it kind of plugs into, let's say, Salesforce and arms the sales team with a new tool that allows them to focus on high value prospects. But at the end of the day, that still is a forward-facing sort of thing that the company's doing. It may be an internal tool, but at the end of the day, it's still a salesperson picking up a call with an existing client or a prospect. And that sort of like gray area is where we see most of this happening. And I think it's because it's kind of a new concept. So they're still kind of testing it with, hey, can we actually run this thing internally that drives some sort of value? But at the end of the day, if we're going to invest in anything, it has to have ROI. So it has to touch our users in some sort of capacity. And that's ultimately where we work a lot with the clients that we have a more hands-on relationship with. We have other clients who run their own data through our platform. They create their own Unity graphs. They normalize it and plug it into the applications that they built themselves. We have no idea what they're doing with it. Those sorts of relationships are becoming more and more regular for us. And that's where I think I see the machine learning training and data access control being a much larger use of the platform than the analytics piece. But I think that's sort of the transition we're seeing in the marketplace.
So, Bryan, we're both in the world of data distribution. Do you want to talk about some of the challenges that you face in that world that might be useful for this audience? So, what are the challenges in actually distributing that data in terms of format and satisfying your customers' expected data structures or data storage mechanisms? How do you look at ensuring that customers actually using the data so you can get your renewals on your licenses? And then lastly, how do you protect your licenses, protect your data to avoid customers effectively all trying to displace you, building their own replacements, or even in some case, data theft?
Yeah, good questions. So we've been working with Bryan and Thomson Reuters for, what, 3 years now, I guess? This has been one of those problems that we've both been tackling, I guess, for a long time now. And I think one of the biggest problems with data is normalization. And I don't mean that from a like structure perspective, but actually from a file perspective. So when the government started publishing open data, and they were like, hey, look at all this like geospatial data and look at all this housing information. Governments were just pushing it out in like shape files, which if anyone here works with the data itself, Shape's a Esri proprietary format. So if I'm a citizen and I want to look at a bunch of data sets that my government's making public to me, I actually can't even open those files on my computer unless I download an open source version of it, which isn't very straightforward, or I talk to Esri about getting a license and actually opening up the data itself. So I think the biggest barrier people run into is they hear an announcement that Toronto is making a bunch of new data available. They run to the Toronto Open Data Portal and they try and download data that's relevant to them, and it doesn't even open on their computer, and they say, okay, this is ridiculous, and they never visit the Open Data Portal again. And one of the biggest problems that both of us have tried to get over is, can we completely eliminate that problem from the marketplace so that people can see data? The first step is validation. It's one thing to say this data is really valuable to your organization, you can build something with it. But if you can't validate that the data looks the way that you think the data looks, then you're never going to use it. And that was one of the biggest problems that we had to get over and are still dealing with. But data ingest is a very, very significant problem that gets overlooked a lot. Everyone just kind of yells ETL. We have an ETL, so we can do it. And it's like, okay, that's cool, I guess. But that's still the average data set taking a couple hours for a data scientist, 4 or 6 hours to kind of run through a process, actually map it, and keep it going. which is fine, again, if we're dealing with internal data that's huge and one or two data sets. But in the world of external data, when you're pulling in small data sets from thousands of different places, spending 6 hours per data set on 1,000 data sets is not a scalable solution to bring data into your environment. And that's where I think when we talk about data normalization, people always are like, yeah, we get it, you normalize data. We always try and say like, hey, but actually we do it for 250,000 data sets. Like this is all normalized, automated. Like that's a big problem to solve. And doing it at scale is significant and one that I think haunts a lot of companies. What was the second part of the question?
Making sure the clients are actually using the data, so they're actually getting the value of it, and they're able to deploy it and mix it with their systems. And then lastly, protecting the data and protecting its redistribution.
Yeah, so we took a bit of a different approach when we started distributing data into organizations, which we found a lot of traditional data vendors were selling seats or API call limits on data sets. And rightfully so, they were making lots of money selling a couple seats within an organization for being used in various different places or charging $1 a row or whatever. Where we said, why don't we take the open data principles and actually apply them to the distribution of data internally. So let's not charge per seat and let's not charge per API call. Let's just charge access to a data set for unlimited usage within an organization. And what we found is adoption is significantly more, there's significantly more adoption because the data set doesn't have any limits. So when we talk to data scientists, they're not scared to send the data, invite someone to the organization to go play around with it. They're not scared to plug it into something that they already have running because they're not scared they're going to get a bill for $100,000 at the end of the day. And that's a big transition that's happening. And any traditional data vendor that's still selling on a seat basis or on an API call limit, watch out, because in this new world where we're looking at training data for machine learning, the API limits and seats doesn't work. I think the buffet's over for a lot of companies that sell that way. And the future is going to be endless amounts of access for data. And people are going to have to make less margin, but provide more data in order to get to those numbers that we've traditionally seen in the big data space. Security, same thing. We never want to take data out of an environment and email it to someone else or put it on a USB stick and send it, although that seems safer because I guess we can hold it. It's super not secure. So what we try and push people to through the platform is invite people to projects and control what they can see. The data lives here, and this is your window into where that data resides anywhere in the world. So it's the safest way to actually access and share data because we can control who sees what and what they have access to and what they can do with it. And that's a big shift that's happening as well. Same thing that kind of happened with Dropbox, and I think why Dropbox created that business, which is shipping documents around isn't safe. Putting them in the cloud and giving people access is way safer. We just kind of have to get over that from a data perspective as well.
My question is on availability. So can you run Namara, I guess, on-prem, or is there some sort of like on-prem caching layer you can do, or something like that, in case your service goes down? Yeah,
so we do it with private cloud deployments, basically. So you can spin up AWS or whatever, and we can drop Namara onto it. And that's what most of our clients do, actually. Yeah. On that note, I think we're coming up right on time. So maybe I'll just say thanks for sitting in and listening. I'm going to stick around for a bit. If there's any questions, let me know. Also, if you're online, that's my email address. I will do my best to answer as fast as possible. But thank you.